Typically, a web application operates within the context of a relatively safe and restricted environment. That isn't to say that there aren't security concerns when developing web applications, but the scope of those concerns are far more restricted than a native desktop application that has far more access to the user's machine. This extra safety also means there is far less we can achieve with a web application. The fundamental thing Electron allows you to do is to build a desktop application where the user interface is implemented as a web application. It achieves this by spawning a Chromium browser within a native desktop application, and it runs your web code inside of that browser. But our main application code is still running inside of a restricted browser environment. So how is it exactly that Electron allows us to access native APIs? Essentially, Electron smashes a little hole through the wall of your web application's jail cell. And through that hole, it passes one of those tin can telephone things that kids used to play with. Electron refers to this method as inter-process communication, or IPC. Let me show you an example. I'm creating a desktop application with Electron using Angular for the user interface. From within the Angular application, I need to allow the user to select a video file on their computer. Then I need to use FFmpeg on the user's computer to generate an audio file from that video and then upload that audio somewhere. Technically, for this specific scenario, using the WebAssembly port of FFmpeg would be possible and wouldn't require Electron or native APIs. But doing it natively in this case is going to be faster, and of course there are a whole host of things you might want to do natively that aren't available in the browser. So I have the user click a button in the Angular application and it kicks off this whole process. Starting with this open file dialog method that is defined on a custom Electron object that I've added to the global window object. So that we have proper typing for this Electron object, I've added types for it in an index.d.ts file here. I assign an interface to the Electron object that defines the API I want to use for my tin can telephone. The tricky part here is that I want to use these types in both the renderer application, which operates in the Angular browser environment, which has a window object, and in the Electron node environment that does not have a window object. So I also have types declared separately for node that use the same interface. Since I'm using an NX mono repo, what I'm doing to utilize these types is to add this types folder to the type roots in the base tsconfig file. Then within any particular library, I can use either the browser or node types for my API by adding either Electron browser or Electron node to the tsconfig for wherever I want to use it. I won't go through the entire API, but we can see the method that we are interested in right now, the open file dialog method, is defined as a function that returns a promise that resolves with either a string, which would be the file path, or null if the user didn't select a file. This tells us that the method exists and how we can use it, but how is it actually implemented? For that, we can take a look at this preload file in the Electron application. And this is where we get to the key ingredients of this jailbreak process: context bridge and IPC renderer. In terms of our jail cell hole smashing analogy, the context bridge is the hole smashed in the wall that separates our jail cell from the outside world. Or in other words, the browser-based rendering process from the node-based main process. And our Electron API that uses the IPC renderer is the tin can telephone that we pass through that hole. In this context, the main world is the browser environment where the Angular application runs. We use the context bridge to expose this Electron object to the browser. When the Angular application tries to use this open file dialog method, it will trigger the invoke method of the IPC renderer. In this case, we just pass in the string open file dialog, but we can also pass in other arguments as well. Then what this open file dialog invocation does is defined in this Electron events file. And finally, we get to the part where the actual native code can be executed. In this case, we make use of Electron's built-in dialog module to display the file dialog and return either the selected file path or null. For something slightly more interesting, we can look at how generate audio is handled by the IPC renderer. In this case, I have a generate audio utility I have created that will spawn a child process and execute the appropriate ffmpeg command and then return the result from that, which will be a path to a temporary audio file created on the user's machine. So that's the basic idea of how Electron's inter-process communication allows us to break the typical bounds of the web browser and access native APIs. Of course, with great power comes great responsibility, and there are many security considerations you should be aware of. A great start is to read this guide in the Electron docs. If you liked this video, consider a like or subscribe before you go, and I hope to see you back here again.